taken to improve wine consistency. So there's a lot of techniques to use to predicting how about the quality of the wine. And I know in our research objective, the first one, we would like to use the machine learning techniques to find the contribution of the physicochemical features. So the machine learning, that this research will compare the machine learning techniques that have been developed to deal with the large amount of data, such as random forest, decision tree, boosting algorithm. And in the boosting algorithm, there's lots of the boosting algorithm, but I will just use 3 of the boosting algorithm, such as ADA boost, gradient boost, XG boost, and also stochastic gradient descent, and the last one is the support factor classifier. Well, the next one is I would like to compare the highest of the machine learning techniques with the deep learning. So the deep learning, I would like to focus to use the multi-layer perceptor will be applied on the research to compare the accuracy with the machine learning techniques. So basically the objective is to compare the 7 machine learning techniques, and then the highest one will compare with the deep learning, which is using the multi-layer perceptor, and then the best accuracy will determine which one of the physicochemical are the most indicative or a good quality of the wine. So the next one, I would like to explain about the related works that we use for our proposed research. So in related works 1, 2, and 13, they show the comparative performance of the machine learning techniques. That result shows that always the random forest that used for the previous related works that have the best accuracy. But is there any, in here, in my proposed research, is there any machine learning techniques that have the highest rather than the random forest or even the same, okay? And then the third one is the showing of the application of deep learning on food science and food safety, and then we will like to applying of deep learning on the wine. And then the total related works is applied the multi-layer perceptron to define the wine quality classification. It's just define the wine quality. How about if we compare with the machine learning, okay? So the next one is the materials and methods. So in here is the data description. So we have the data is available in research purpose from the UCI machine learning repository. Second one is the data has 1,599 red wine, and then we have 4,898 white wine. So basically we would like to use the red and white wine. And then the third one is the data has 11 physicochemical features, which are the 11 characteristics of the quantitative evaluation as input variables. And then the output variables will use the quality of the wine itself. So the quality itself, it has the rating between 3, which from very bad, until very excellent, which equal to 8 for the red wine. And then for white wine, we have the wine very bad, that's equal to 3, until very excellent, that's equal to 9 for the white wine. So next one is, here is the data description. So in here, the data description will figure 1, it's the correlation of the red wine, each physicochemical wine features. So in here, the red wine, we can see here that we have the fixed acidity and then the pH that have the close for the perfect relationship between the correlation of the physicochemical in red wine, and also it has the free sulfur dioxide and total sulfur dioxide that also have closer to have the perfect relationship of the data description. And then the next one, it have the white wine, okay, and then it will have the white wine that for each physicochemical wine features that have the correlation, and we have the 0.85 of the residual sugar, and then the density that have the correlation, And also we have the density and then the alcohol that have closer with the perfect relationship within the correlation of the white wine for each physicochemical for wine features. And then the next one is I would like to explain about the data mining approach. So in here I would like to explain about the machine learning process first. So the first one is we define the problem. So the problem, it means that we have determined the contribution of each physicochemical feature of the wine quality, and then the data gathering that has published at the UCI machine learning repository. And then the third one, we have data cleaning to check any duplication, null values and missing values or error, etc. And then the fourth one, we have the data visualization and exploration of the variables. That means that interpreting each feature of the red and white wine data. And then the fifth one is the train of the machine learning algorithm, that's such as of the random forest, decision tree, boosting algorithm, ADA boost, gradient boost, XG boost, stochastic gradient descent, and the support vector classifier. And then the last one, we will like to evaluate the model which define the important physicochemical features in red and white wine using the highest accuracy of the machine learning algorithms. So the next one is the data mining approach of the multi-layer perceptron or using the deep learning. So the first one, we would like to explore in the visualizing the data which consists of the red and white wine. So the next one is the pre-process the data by splitting up the data into the train and test sets and standardizing the data that will be used. And then the third one will build up the multi-layer perceptron for classification text. Fourth one, compile and fit the data for these models. And then the fifth one, use the model to predict the target value and validate the model, which we'll use for predicting the most important features for the quality of the wine. And then the next one, we have the experimental result. Okay, so here is the experimental result for the 7 machine learning techniques that classifying for the red wine. So in here, we have decision tree techniques until the gradient descent. So here we see that the random forest techniques that use for several previous related words, that we have the highest accuracy value. Yeah, it's same with the previous related words. But we can see here, is there any have the highest accuracy rather than the random forest? But in here, even there is not any higher accuracy rather than the random forest, we have the XGBoost techniques that haven't used from their previous related words. We have the accuracy which 92%, that's equal to random forest techniques rather than the another machine learning techniques. This is for the red one. And then the second one is for the white one. So in the white one also have the same one, which equal to 86% of the accuracy that resulting from the random forest and then XGBoost. So the conclusion is the results that random forest and XGBoost are the highest levels of the accuracy, but have the same accuracy value. The red wine accuracy value is 92%, and then the white wine accuracy value is 86%. The question is, why the white one can be lower than the red one? Why? It's all because the data of the white one is bigger rather than the white one, rather than the red one, sorry. Because just know that the red one have 1,000 more, right? And then the white one, they have the data which include 4,000 more. So the more data, it could affect the accuracy of machine learning techniques. And then the next one is, here is the indicative important physicochemical features of the red and white wine using the random forest techniques. So because the random forest and the XGBoost have the highest accuracy, so we can see here that the alcohol here, the alcohol at the indicative good quality features of the red one using random forest, and then here is the white one. We can see here that the alcohol have the highest of the indicative good quality of the wine itself that used for the red and white wine. And then the next one, how about the XGBoost? So here using the XGBoost, we can see here that the higher which we have really drastically that the alcohol have the highest that influence the indicative good quality features of white and red wine. So the next one. So in here that the experimental result from the graph before the feature that C XGBoost and then the Randall Forest shows the alcohol have the most indicative feature to define the good quality of the wine. So the next one is the experimental result of the deep learning, or we can say the multi-layer perceptron. So the accuracy here, the accuracy result of red and white wine using the multi-layer perceptron algorithm. So we can see the algorithm it's really have higher accuracy, right? And then the loss function also it's so lowers. So what's that mean? It means that the result is based on the multi-layer perceptron accuracy, yielding the highest accuracy rather than the random forest and then the XGBoost techniques. Deep learning shows 97% accuracy for red and white wine, and the loss function yields 0.086. So it means that the lower of the loss function, also the higher of the accuracy. So here is the experimental result of the correlation between alcohol and the quality of the red wine and also the white wine. So before that, the rating of the good from the very bad until very excellent, we can say that the for the red one, we have the 3 and the range 3 until 8. And 8 is the very excellent that we can say that the value of the alcohol, the higher of the value of the alcohol, the higher of the quality of the wine. And then also here we can say that the white one have the range very bad until very excellent, and the very excellent equal to 9, which have the higher of the alcohol, which better of the quality of the white wine. So now we would like to move on the conclusion. So the highest accuracy is taken by XGBoost and Randall Forest that resulted in the accuracy 92% for a red wine and accuracy result 68% for the white wine. The result of multi-layer perceptron is yielding an accuracy 97% and the loss function is 0.086. And the important physicochemical features that define the quality of red wine and white wine shows the higher level of alcohol shows a good quality of the wine. So that's all from me. Thank you so much for your attention.